Hello, and welcome to a bit more serene talk after lunch than what I did yesterday morning. This is probably the one with the most pretentious title of the entire conference. It's not going to be in French, even if the title is in French, but the talk was inspired by a movement in French absurdist literature that arose in the post-war years called Oulipo, and it had members who were writers and mathematicians really experimenting with literature. And I just took the title from their movement, and it really means Workshop of Potential Code. And this was all inspired by when I discovered this book by Georges Perec, La Desperation, or A Void, which is called in English. It's a 300-page novel written in 1969 without using the letter E at all. And the letter E is the most common letter in the French language. So it's quite a feat to do that, write 300-page novel. It looks like this. Without using the letter E at all. There's an even bigger feat translating this into English. There is an English translation of this book as well, because then you do not get to choose what words to use and how to tell the story. So I'm learning about this book. I asked myself the question, what would a similar thing be if we applied this to programming languages, which is what this talk generally is about. So sorry for presenting you with a bit of C# code. I promise there will be some Java as well. So I thought about what would FizzBuzz, the classic programming exercise that everyone has done, be if we take away the most commonly used keyword in the C# programming language, which is obviously the if statement. And we also take away the ternary operators, so we cannot use the classical ifs. So what I came up with was doing something like this and using the pattern matching features of C# and a switch statement, which incidentally made this code much more condensed, and some will say maybe a bit more concise as well. Since we're at the Java conference, let's do the same thing with Java. This is my attempt of doing FizzBuzz without conditionals in Java. And luckily in Java 14, we got an improvement to the switch statement in Java as well, so that you can pretty easily do it this way. I do not find this as elegant as the C# one, so bear with me, we'll stick with C# for a while now, because one of the things I discovered was that writing it this way in C# is that I had really invented Haskell. Because this is the way you actually would go about doing FizzBuzz in Haskell. And this sort of teaches us something, that C# being an object-oriented programming language that has grown into having many functional capabilities as well, gives you opportunities on how you write your code, and you can sort of choose your dialects. And you can write functional code in C# as well. So just introducing limitations makes you think in different ways. This is another interesting book. This is a book that's called 100,000 Billion Poems, and it actually has that. It's a work from 1961, French writer Raymond Queneau. And it consists of 10 sonnets. All of them have the same rhyme scheme and structure, but there are strips of paper that you can turn across, so many small pages within the book. And you have 10 choices for the 14 lines, and you can make out what a huge number that becomes. If you find this in a second-hand bookshop, it's really super expensive. So I do not own this volume myself, but I figured this is an experiment for using generation of code to come up with the correct FizzBuzz answer. So this is what I came up with. This is a piece of Python code that generates Python source code. And there were some interesting problems I ran into or bumped into while doing this, because you have to introduce a sense of randomness to get different outputs every single time. But this randomness can't be entirely random, so I had to, instead of using the random library, use the hashing library, which will produce a different output every single time as the seed for the randomness. And then it's just to run through this, as the function name says, take a shot at getting Fispus right, and then execute that code and just compare it to the expected result. This is not really a efficient way of writing code. I had to ask a grown-up how many iterations it would take before it would get it right, and that was something called a novemedicillion. I'm not sure if I'm pronouncing that right, probably not. You can think of it as an astronomically large number. But it's a way to solve a programming problem that you should probably not do. There are so many interesting books that were written by this Oulipo movement in the post-war years, and this is another one by George Perec. It's the User Manual for Life, and it's about people living in a Parisian apartment building. But it's also a puzzle, and it's inspired by the Knight's chess problem, which was a chess problem that a mathematician came up with, which is all about moving the knight about around the chessboard and visiting all of the squares on there. So this is one of those interesting programming problems that you would probably bump into if you do something like Advent of Code. And I wanted to switch this up and combine it with another book. This is another one by reimagining as well. This is one of the first books that were published in the Oulipo movement, and it's called Exercises in Style. And it's the same story told 100 different ways. So short story, but in 100 different styles of writing. So it sort of shows the playfulness of language you can use as a writer. So I decided to combine these two. So let's imagine that we have some more squares on the chessboard, so it's a 10 by 10. Then we have 100 different opportunities for solving this problem. And we can start working our way around. So there are so many ways that the Knight's Tour can be solved. The most obvious way of solving it is applying something called the Wondorf's rule, which is a mathematical approach to this, where you limit or you look for the square with fewest onwards moves and reducing the chance of the knight getting stuck on the table. So if you should wonder, this is the proper way of solving this problem, but I like to do things improperly as well, so I started experimenting with other ways. This is the naive algorithm you can use. It's backtracking and just exploring recursively all the possible moves and undoing steps that lead to a dead end. And you keep repeating that until a complete tour is found. It's a fairly simple algorithm, and this is probably what you would use as your first take on some of the Advent of Code puzzles. But there are other ways. This is an interesting one. This is a approach that you probably never would use at work, but it's one that is interesting to know about. This is something called an ant colony optimization, where you have virtual ants just wandering around on the chessboard and leaving behind virtual pheromones for the other ants to pick up on, and then reinforcing shorter or more successful tours across the table, so the ants guide each other along, which is a problem-solving algorithm that can be used in quite a few scenarios. There are many ways of doing this. This is yet another one. It's a branch and bound algorithm. It's a optimization problem style way of solving this. You could do something called a breadth first search. This is one I see used quite a lot when people try to find solutions to problems in writing code. It's a bit complex, but not too complex to wrap your head around. It has a sibling as well, which is step first instead. This one is really common, trying to find a pattern in data. But you could also use genetic algorithms, where you have genes that sort of evolve the algorithm in an evolutionary manner. It's a programming style that was really popular in the 1970s. Do not really see it that often today, but it's one of those ways that people used to solve problems historically that might come in handy one day. This is a particularly dumb idea. It's using dynamic programming for it, so I won't delve into the details of that. This is one that is relevant to the way we build AI systems these days. It's a Monte Carlo tree search, which is yet another algorithm to this. I won't go through all of the hundreds because that will be a bit tedious in the end, but I actually sat down and solved this in 100 different ways. I do not recommend you doing that yourselves. But why am I doing this at all? And the thing is that constraints are very often seen as limitations. They are basically boundaries that box us in, but the writers of the Oulipo movement didn't see it that way at all. They saw the restrictions as invitations to think sideways, to reinvent and to surprise themselves. And as programmers, we often aim for elegant, efficient, and idiomatic solutions. But once in a while, it's healthy to just step outside the comfort zone of convention and create some space for discovery. Because we find different and new paths to old problems that we have stumbled upon before. We discover things in the programming languages that we have maybe forgotten about or maybe not even ever learned, like doing functional programming in C# in the style of Haskell. And when we do that, we can make familiar tasks strange again. And through that, we make them interesting, and it inspires us to learn new things. Because it's all about finding what appears in the spaces between all of the things we know. And I'll leave you with those words of inspiration, and thank you so much for coming to a talk on French absurdist literature just after lunch. Thank you so much. So this is a bite-sized talk where we actually have 2 minutes for questions if somebody should be curious about something. Yes, sir. So the question was if application of this in front end would, while especially related to using frameworks. It's a perfect scenario for doing this. Take baby steps. Step outside of the convention of using the frameworks that you're used to and try using something different. You might discover that the frameworks you are used to are inefficient compared to others, or you might find that they are the best ones that are the options, but you will still get the cultural influence from the other frameworks, and you might also discover things like you might be using this tiny little framework that you could easily implement yourself, and you rid yourself of a dependency in your code. So please do experiment. We have 49 seconds for another question if someone has something. Otherwise, I will let you go out and head on to the next bite-sized talk that you want to see. Thank you so much for coming.